David Smith here with another flipped classroom math lesson. A few tips before we start. First, remember that you can speed up or slow down the playback if that helps you follow along. Second, you can turn the captions on and read my words on the screen. Third, you can pause the video at any time to catch up with your notes or write down questions for class. Today's lesson covers transformations of rational functions. So far, we've been working with a very simple form, which is f of x equals k over x. No complexity there, and we've been playing around with that function. Now we're going to start adding things into the mix and taking a look at how the graph of that function transforms. So you'll need to remember about your asymptotes, because I'm going to ask you to make 5 graphs, label your asymptotes, and then come back to the video. So check this out. Here are the 5 functions. We have our basic y equals 1 over x. We have y equals 1 over x plus 2, y equals 1 over x minus 3, and then we have 1 over x plus 2 outside of the denominator, and the same thing here, 1 over x minus 3, again, outside of the denominator. So what I want you to do, pause the video, use your graphing technology tool, either like Desmos or your calculator, and create quick 5 sketch graphs. And I want you to label your asymptotes because these are super important for these graphs. So pause the video, go do that, and come back. All right, let's take a look at your graphs, compare with these, and make sure we get these points here. So here is our basic rational function, y equals 1 over x. So asymptotes are the horizontal and vertical axes. So we don't need to label those. Those are just part of the graph. Now, when I graph this one, x plus 2, what I notice is that the asymptote shifted over to minus 2. So that vertical asymptote is now x equals minus 2, but the horizontal asymptote is the same. So this graph has shifted over to the left by 2. Notice how that's the opposite of the sign there. So that can be a little tricky. Now notice here that we have a minus 3, and the graph has shifted over in the positive direction to 3. So we have x equals 3 as our vertical asymptote, and again, our horizontal asymptote is the same. Now moving along to this version of the equation, now we're adding or subtracting outside of the denominator, and you'll notice that the plus 2 shifted this graph up by 2, but it kept the vertical asymptote the same. And then finally, when we go to 1 over x minus 3, again, outside the denominator, we've shifted the graph down with the horizontal asymptote of y equals minus 3, okay? So you can start to see the pattern here with the adjustments we're making in our rational function. Now let's make some general statements concerning what we learned from those 5 graphs in the last board. So check this out. For functions in the form, f of x equals k over x plus d in the denominator plus c outside the denominator. Now we're going to be able to say something about our vertical and horizontal asymptotes. So I want you to pause the video and you can write a short little equation for each one of those using the letters above. So if you remember from our last board that this one, the d here, that controls our vertical asymptote, and it's switched. So if it's plus d, then the asymptote is at negative d. So that's why the vertical asymptote equation is x equals negative d, like that. And then you notice with the horizontal asymptote, we didn't have that sign switching issue, so it's just plus c. So then the equation for the horizontal asymptote is y equals c. All right, what I want you to do is pause the video and use what you just learned to sketch 2 graphs. So I have this one, 1 over x minus 3 plus 4, and then I have this one, which is a little bit more complicated. I have 1 over minus x plus 5 minus 2. Now this is possible to do these pretty quickly without the calculator, but if you want to use your calculator, you can go ahead and do that. So pause the video, make your graphs, and come back. All right, let's do these one at a time. So here's my first graph, pretty straightforward. My vertical asymptote is at x equals positive 3, so I sketched that first, and then my horizontal asymptote was plus 4, so I sketched that first. And this is the way to do these, is to sketch your asymptotes first, because then your curves kind of nestle right in there. So here's my quadrant 1 section of my curve, and here's my quadrant 3 section of my curve. So that's a quick and easy sketch. I didn't use my graphing calculator to do that. I just sketched it based on what I know. And then you'll remember, if this number gets bigger, the curve moves out from the kind of the connection point of where the asymptotes are, and if this number gets smaller, the curve moves in towards that junction. So now this one might have caused you a few conniptions because I have a negative x out there and we didn't really treat that specifically. Fortunately, it's a pretty easy fix. So I'm going to show you how to do that and then turn you loose to graph. So check this out. This phrase here, negative x plus 5, can be rewritten as negative 1 times x minus 5. So all I did is I factored out a negative 1, and that gives me my positive x, which is what I'm more familiar with. So then I can take this one more step. This negative 1 is now on the bottom of the fraction. So positive 1 divided by negative 1 gives us negative 1 on the top. So now I can write negative 1 over x minus 5 minus 2. So I just subtly reworked this function to make it look more familiar so I can quickly and easily graph it. So if you didn't already graph it, now I want you to do is pause the video, draw your asymptotes on your graph, and then put in your curves. All right, let's see how you did. So the first thing I did was I graphed my horizontal asymptote at negative 2 from that point there, and then I graphed my vertical asymptote at x equals 5 because we switched that sign. So I've got those both in, and then critical thinking step. Remember, now this is negative, so that means the graph is going to go in quadrants 2 and 4. So I sketched my curves right in there, nestling into my asymptotes, and I'm done with that one. All right, so one last thing we'll do with these graphs. I would like you to state the domain and range for each of these two graphs. So use what we learned about domain and range in the last lesson and write out a statement of domain and range for this graph and a statement of domain and range for this graph. Let's take a look at this first graph. And before we get into the technical statement of the domain and range, let's just talk about it in a qualitative sense. So what does this graph show you that x can't be? It's the asymptote. Remember, the asymptote is a value for x in this case that the function can approach but never quite get to. So the domain, it can't be 3, but it can go as far as it wants to the left and it can go as far as it wants to the right. So it goes out to infinity. So basically, it's the set of all x such that x is an element of real numbers. It can be anything except x is not equal to 3. Okay, so that's pretty much it. Now the same argument goes for y. What can't y be? And that's the horizontal asymptote. Again, the function is going to approach positive 4 as x goes out to infinity. And the function approaches positive 4 but never gets to it. Same thing as x goes to infinity on the negative side. So this asymptote shows us what the range can't be. So again, it's very similar. The set of all y such that y is an element of real numbers but y is not equal to 4. Okay, so pretty straightforward. If you understand your domain and range, this shouldn't be too challenging. Now quickly taking a look at the second graph, our asymptotes are now, the horizontal one is negative 2, and so that's what influences what y can't be, and the vertical asymptote is at 5, so that's what shows what x can't be. I'd like to introduce you to an alternate notation for domain and range. You might see this in your textbook or elsewhere in your travels through mathematics, but it's a little simpler, not much. I do prefer this notation because it's very specific and it's more formal, which I like, but this works just fine. So this brings us to the idea of set notation. So these U's stand for union of. So what we have is this interval from negative infinity to 2, and it's unioned with the interval of 2 to positive infinity. So this is basically bracketing negative infinity to positive infinity, but we can't quite include 2. So maybe not quite as clear as this notation either. Now, same thing here for range. We're just going from negative infinity to 4, exclusive, doesn't include 4, and then going from 4 to positive infinity. Again, using the union symbol to say that the range is the combination of this interval and that interval. Okay? Now, what I want you to do is pause the video and use this new notation to specify the domain and range as we wrote there. So, here you go. We have negative infinity to 5 unioned with 5 to positive infinity because it just can't be 5. And the same thing for the negative 2 exclusion from the range. So here we go in the same notation. So I will accept either notation on any quiz or test that I give. And I believe if you're in an IB class or IB test, you're going to either way to specify your domain and range will work. Now that you've finished the video, take a moment and jot down some notes or questions for our next class. Remember that you can also watch the video again if you want to increase your understanding. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.